So hello everyone, this is the channel about engines. Today we're going to take apart this engine. It's a Mercedes-Benz 501. It's been a while since I've had a 501 on the channel. I haven't repaired engines for a long time, so I think it's about time. So a little background on this engine. This engine belongs to one of my subscribers from Moscow, and it was taken out of this kind of vehicle. Not so long ago, this engine was repaired somewhere in Moscow, I don't know exactly where. Basically, they machined the main bearing seats, and after that, the owner started having problems. The valves are hitting the piston, getting stuck, and basically they removed one cylinder head, then the second, then the third, several times. They did all this multiple times. I don't know exactly how long this engine ran or what the mileage was after the repair. And now, as far as I remember, on the fourth cylinder head, the valves broke off. They hit the piston, the valves broke. So the customer decided to remove the engine and send it to me for repairs. So now another engine has already been installed in the car, meaning the car is already running. This engine will be rebuilt or maybe used in another car. It's a pretty slow repair for us. For now, we'll take it apart and see what's wrong with this engine. Then we'll make some decisions, order the parts, and maybe there will be some downtime, so the repair might take 2 months or maybe even 3. Since a rebuilt engine was purchased, all the attachments from the rebuilt engine were removed and installed here. It's just so we have a complete engine set. So everything from this engine was removed and installed on the rebuilt engine, which is now installed in the car and working. So if we look at the condition of the wiring, at first I saw it and didn't understand. I thought, how is this possible? What is this? There are wires sticking out somewhere, everything is cut, everything looks like this. For example, the pump is all rusty and turns with difficulty. It's all rusty and turns with difficulty. And somewhere here the grooves are dented. Well, the same goes for the tensioner pulley, the alternator, and so on. All of this was installed from the rebuilt engine. The same applies to the turbocharger. Here you can see some nuts are cut off. Somewhere else, well, in general, everything is in this kind of condition. Well, I also want to show that during transportation, the air manifold was broken. It was crushed like this. So, this spot here was the point of pressure. The engine pressed against it, and the manifold got crushed. This whole thing here is the spider manifold. As an option, of course, you could cut something out here or weld something. Well, I informed the customer and he said we'll get a new spider manifold. The air manifold was in good condition. Well, I don't know. There are some disputes going on with the transport company. By the way, it's Delovillini, or maybe there aren't. I don't really get involved in that. Also, I'll say that the engine was installed and packed in a really strange way. It was shaking and wobbling all over the place. It was on this frame, but for some reason it was installed the other way around. And there were some pallets here. Basically, I have no idea how the engine was packed. I don't think I've ever seen anything like that before. Although there was a frame, they just needed to turn it around, put the mounts on the frame, and maybe put something underneath somewhere. Honestly, I don't know. Now about the engine, about the block, as I already mentioned, some machining work was done there. And now I'm thinking that maybe they machined the bearing seats incorrectly, like they shifted the axis too much this way, toward the center of the engine, toward the cylinder heads. Maybe we won't even be able to do anything with this block now. One option, I think, is that we might have to actually replace the block, or look for another one, or maybe even buy another engine. Well, these are just my initial thoughts, but maybe our machinists will be able to fix everything. I don't know, we'll see. So I'm starting the disassembly. First, I'm removing the turbo, the intake manifold, the exhaust manifolds, the wiring, and then the cylinder heads. Basically, I'm doing everything step by step. So, that's the scope of work we have. Let's go. So I've removed the cylinder head screw and I'm trying to figure out why the pistons are hitting the valves. Right away I notice there are valve marks on 5 cylinders. Here we have the second and third ones. The fourth, fifth and sixth, some have bigger marks, some smaller. For example, on the sixth one you can see it visually, but you can't feel it by touch. On the fifth one you can also see it, but you can feel it just a little. On the fourth one it's very visible and you can really feel a dip, a ridge, a step. So it turns out that on the fourth cylinder we have the biggest dent from the valve, except for the first cylinder. And there's an interesting point about the first cylinder. I'll mention it now. First, I'll say that I already know for sure this lifter will need to be replaced. We can see it's in this condition. It's all chipped here, plus the guide has fallen out. It looks like it was spinning in there, and as a result it was splitting along the cam lobe. Also this lifter, this roller was set at different angles, so the lifter definitely needs to be replaced, and the cam lobe was also split and worn down by these rollers, so the cam lobe also needs to be replaced. That's 100%. Well, this one turns out to be the most damaged lifter, and some of them are in this kind of condition, half chipped, as you can see. Basically, almost all of them are like this, so all the lifters need to be thrown out, and the cam lobe also needs to be replaced. That's 100%. Now about the valves and pistons. Why do they collide? So I'm flipping through some literature here, recalling some things from memory, taking some things from the books, trying to figure it out. I've already measured the protrusion of the sleeves above the cylinder block. Basically everything is fine. It's about 25 to 27 there. According to the literature we have up to 30 to 30. Here we have 25. So basically everything is fine. There are no complaints. Next I measured the piston protrusion above the cylinder block. Here, as we can see, the block is at 0. The piston is plus 0.22 millimeters. Once again, the block is at 0. The piston is plus 0.22, the piston is 0.229 thousandths of an inch. According to the manual, the piston protrusion relative to the cylinder block is from 0.27 to 0.61. This piston has a protrusion of 0.2 millimeters. That means it's 0.05 millimeters below the standard half a tenth, and it could still be 0.4 millimeters higher. And at the same time, it shouldn't come into contact with the valve. So the piston protrusion is all good. The liner protrusion is all good. I checked all the pistons, and the protrusion is about the same on all of them. Well, give or take somewhere from 0.15 to 0.25 millimeters. So they're all below the standard, and you can see that they were machined on a lathe. This spot has already been machined. They took off more than necessary with a margin, and still the problem didn't go away. Still, our valve is hitting the piston. Next, what else did I do? I measured how much the valve is recessed. We also have certain parameters for that, and it turns out the valve recession relative to the cylinder head joint surfaces is from 0.7 to 1.05. So it comes out to 0.7 tenths, and roughly speaking about 1 millimeter. Let's say 0.1 if we round it, or exactly 1 millimeter. This is the measurement from the cylinder head mounting surface to the valve itself. It should be 0.7 to 1. So let's check our cylinder head and set it to 0. Well, and now we move to the valve and check. Here we have 1 millimeter, 1.2, 1.3, 1.4, 1.45. That means the valve is also set lower, further from the piston. Well, I've already measured everything. Also, let's look, for example, 0 mm, 10, 20, 30, 35. That means all the valves are lower than they should be. The piston is further from the head. The valves are further from the piston. So we have clearance everywhere. I don't have an explanation yet for why the piston is hitting the valves. I can't figure it out yet. Now, let's go back to the first cylinder, where we don't have any valve marks. So, as we can see, the piston is completely clean. There are no marks anywhere, which means the piston protrusion is exactly the same. We see that the block is at 0. The piston is at 17 hundredths. Well, it's 4 hundredths lower. Well, there might be some misalignment here, so the protrusion is about the same, give or take a few hundredths, but that's not so important anymore. But what we see, the most interesting thing is that this piston is different. I'm not sure how well you can see it on camera, but the combustion chamber, for example, on these two pistons, and the combustion chamber on this piston. Now let's take some measurements. We see 92.5 millimeters, maybe 92.7 here. The diameter of the combustion chamber is 92.7. And now, let's say we look at the piston that moves synchronously in a pair. Here we have 86. So there's a difference of 6 millimeters. This is the main point I've noticed so far. We have 5 pistons that are the same with this kind of combustion chamber. And all of them have a valve imprint. Here we have one piston with a different combustion chamber, and it doesn't have a valve imprint. I've already come across pistons like this where they have different combustion chambers. Most likely, well, based on my experience, most likely these pistons are from MAL, and this piston is from KS, so they come under the same part number as if they're interchangeable. But they actually differ in the combustion chamber, and I think there are some other differences too. I just don't remember right now. So for now, that's the only thing we can go on. I don't have any other ideas why exactly the piston is hitting the valve. Well, okay, now we'll take it apart again and see what's going on with the crankshaft itself and the bearings. Like I said, the main bearing seats have been machined. Maybe that's the reason. But again, if the crankshaft had shifted too far this way, then the marks would be on every piston, on every cylinder, all in sync. So it wouldn't matter if it's the first, third or fourth, the marks would be the same everywhere. My engine is disassembled, and what can I say? Well, first of all, I haven't found the reason why the valve is hitting the piston. I took all the possible measurements. That's the cylinder liner protrusion above the engine block. That's the piston protrusion above the engine block. That's the piston compression height. That's the total length of the connecting rod. That's the valve seat depth. That's the maximum allowable cylinder head height, and so on. So, I think I've already checked and looked at everything possible. And for now, I have no idea why this is happening. I also took apart one cylinder head. This is our second cylinder, where the biggest marks were on the piston. Also, basically everything here is fine. The valves, I think, were even replaced with new ones. I saw somewhere there the inscription original equipment Germany, but again we have one piston here that has the same compression height, the same protrusion above the block, but it doesn't have any valve marks on it. So regarding these pistons, both of them are made by the company Mal. We can see the Mal inscription on both pistons, and both pistons also have the Mercedes logo. Well, as I've mentioned many times before, Mal is the supplier for the assembly line. These pistons have different numbers. Here it's 130L, 134 plus, and here 130L, 118. The pistons have different numbers, obviously. They differ in the combustion chamber, and they also differ in height. Well, basically by the position of the piston ring grooves. That is, we can see that on this piston. All the rings are shifted a bit closer to the crown. They're shifted by about 5 mm, give or take, that is regarding the block, about the groove for the main bearing shell. Looking at the block here, well, it's clear that something was done to it, but I have a kind of strange feeling about this work. For example, if we look at the block itself, the seating area where the cap sits, there's a dent here, like an imprint from that cap. It's probably clearly visible on camera. I mean, you can see it visually. It's more than 1/10 of a millimeter, about 1.5 tenths or so. For example, it's there on the second cap, on the third cap, and on the first and fourth it seems to be a bit less. So usually these spots are also ground down here. If we look at the cap itself, you can see that this area has been ground. You can see that the guides were clamped in a vise when they were removed, so it's clear that some work was done with the caps. If we look at the actual seat, where the bearing shell sits, it's also kind of unclear here. The marks here look kind of like honing. If machinists are turning it on a lathe, it looks completely different. There's a clear mark from the cutter. Here, we can see some kind of honing as well. This is what I don't understand, how they do this. Maybe they turn it first and then somehow finish it to size. Well, in general, I don't understand how this was done, but you can see that it was done on a machine by hand. You just can't make such straight lines and intersections at that angle by hand. I also checked the caramel slow, the bridges on the valves, and also checked if maybe our rods were bent. The gap is set to one value in one spot and a different value elsewhere, so I didn't find anything wrong here. Everything is fine, the rods are straight, flow is in good condition, and the bridges are too. There are no complaints. So now about the camshaft. This is the camshaft from this engine, and this one I had before. I think it's Euro 2. And this one is Euro 3 or Euro 5. I don't remember exactly, I need to check by the camshaft. As I said earlier, it's for disposal and that's how it is. We can see the wear here. It's not just tenths, it's millimeters. The cam lobe is worn down by about 2 or 3 millimeters. So, what I did was mark the timing marks on this side of the gear. At half, marked on this side, and made this kind of marking based on those marks. Well, obviously there's a margin of error of a couple of degrees here, but still, it gives me an idea of the cam lobe's position. So, I took my Euro 2 camshaft, did the same procedures, and what I see is clearly visible on this cam lobe. If on this camshaft, the width of the cam lobe and this mark ended up about 1/3 of the width of the cam lobe. If we look at this camshaft, the width of the cam lobe and this mark are almost exactly in the middle. Well, here it's literally just a couple of millimeters short of the center. Let's look again on this shaft. It's clearly visible that on this camshaft the cam lobes are shifted a bit to this side. It turns out on this one to this side. So I have two explanations. The first is that the gear here has slipped, the timing phases are off, and because of this the valves are hitting the pistons. Well, obviously if the timing is off, the valves open at the wrong time, not when they're supposed to. But again, this should have a big impact on how the engine runs. That's the first thing. Second, we should only see marks from one set of valves. Let's say only the exhaust or only the intake valves, because the cam lobes are shifted to one side, and it's the same valves that come into contact with the piston. We have marks on the pistons from both the exhaust valves and the intake valves. Well, of course, most of the marks are, in my opinion, from the exhaust valves. But that's my main theory for now as to why the valves are coming into contact with the pistons. That is, this gear has slipped and the timing phases are off. Or there's a second option. It's that the camshaft isn't from this engine, meaning during the last repair the camshaft was replaced and they installed the wrong one. So for now I still think that we have an issue specifically with the camshaft. Either the wrong camshaft is installed or the gear on the camshaft has slipped. Well, I don't know. Usually gears slip on inline 6-cylinder engines where the compressor drive is located right here. When something happens to the compressor, it seizes up here. The gear slips on the shaft, but on these camshafts I've never seen a case where this gear was slipped relative to the shaft itself. I still can't explain why the pistons are hitting the valves. We'll keep thinking about it and I'll discuss it further now. I'll ask the customers for more details about what work was done on this engine, how much it has run since the repair, and so on. So, now about the condition of the engine. Well, it's clear that it was repaired, that something was done to it. Well, for example, the camshaft bushings weren't replaced. You can actually feel the wear just by touch. If we keep this block, then the bushings definitely need to be replaced by a machinist. So, they can change the bushings, machine them, and so on. But so, regarding the bearing caps, I can't just leave them like this either. If we keep this block, again, it needs to be sent for machining, so everything is done properly and the bearing caps are machined. We still have a choice. We don't know how much material was removed or which way the shaft shifted. And if we machine it again, is that even possible or not? And also, if we keep this block, we'll definitely need machine work on the cylinder head mounting surface and the camshaft. And the camshaft must be new. As I showed, we have this kind of wear here. Everything's worn out. And the camshaft will need to be selected specifically by the vehicle identification number code. As I already mentioned, it's possible that the camshaft we have installed is not the right one. This camshaft won't fit. Mine is Euro 2. So the sleeves need to be replaced because of the pistons. Here we can see these kinds of scratches on the skirt. I don't know where the metal shavings came from. But in my opinion, my version is that after machining the bearing seats, they didn't clean the oil channels and remove the plugs. And in general, they didn't blow out or wash anything there. The cast iron shavings remained and they went through the system. We can see that some pistons have bigger scratches, some have smaller ones. And the sleeves were also damaged. There are similar scratches on them. And I don't know. I can't figure out if the sleeves were replaced during the last repair or not. It's possible the sleeves are still the old ones. So as for the connecting rods, all the bearings are sitting loosely, both in the rod itself and in the rod cap. I think it was visible in the video that when I remove the cap, the bearing stays on the journal, and it's the same with the connecting rods. The piston pin bushing definitely needs to be replaced. There's a huge amount of play. I'm not sure, but I think it's visible on camera. So the bushings and the connecting rod definitely need to be replaced. And also the seating for the connecting rod bearings needs to be checked. If we have any defects, then the connecting rods should be new, because a cracked connecting rod can't be restored or repaired. There's nothing you can do with it. As for the crankshaft, well, as far as I can see visually, everything seems fine, but measurements need to be taken, and I haven't gotten to that yet. As for the cylinder heads, they'll be sent for surface grinding. we can see there's a sort of pit here. I don't know if anything was done to this surface during the previous repair or not. Also, it's necessary to replace the guide bushings and exhaust valves. There's this kind of play. If the intake ones are still more or less okay, the exhaust ones definitely need to be replaced. Well, as for the rest, I think everything is standard. We'll check the water pump and it might need to be replaced. We also need a new turbocharger because this one is from a used engine and it's all covered in oil. The compressor needs to be repaired and so on. In general, everything is pretty standard. And as I showed, we need this air manifold, a new one. Well, not new, but used and in good condition. I'll be ending the disassembly series here. Thanks for watching, good luck and goodbye.